We often view the solar system as a perfectly balanced cosmic neighborhood, safely anchored by a friendly, static star. To see the actual scale, we can use Earth as a baseline. Approximately 1.3 million Earths would fit inside the volume of the Sun. This data visualization shows the distribution of mass in our system. The Sun accounts for 99.86% of the total. Jupiter, Saturn, and every other planet, moon, and asteroid combined represent a rounded-off fraction of a single percent. The solar system exists as a single dominant star, surrounded by a faint dusting of floating debris. We live on one of those tiny orbiting crumbs. The Sun is often compared to a giant floating campfire, yet space is a vacuum with zero oxygen. Standard combustion is impossible here. Instead, the star shines through nuclear fusion. The warmth felt on a summer day originates from a continuous, gravity-contained nuclear explosion. Deep inside the core, immense gravity crushes inward from all directions. This physical pressure overpowers the natural resistance that causes atoms to repel each other. As the diagram shows, hydrogen atoms are forced to combine into a single helium atom. Because the resulting helium weighs slightly less than the original two atoms, the missing mass transforms into energy that pushes outward against the crush of gravity. This energy begins a chaotic journey through the ultra-dense core. Instead of flying straight out, light packets crash into particles and fire backward in a microscopic pinball game that lasts tens of thousands of years. By the time sunlight hits your face, you are feeling energy born deep in the core before human civilization existed. The Sun frequently hurls billions of tons of charged particles into the dark void, sent straight toward Earth. Rather than striking the surface like a physical meteor, this wave specifically targets and overloads electromagnetic systems. In 1859, the Carrington event sent surges through simple copper telegraph wires, igniting fires. Today, that same wave would engulf a fragile web of thousands of satellites, global GPS networks, and massive power grids. A storm of that magnitude could cause trillions in damage, reaching across space to switch off our modern world. The life-friendly star we see every day is temporary. Its primary fuel source, hydrogen, is finite. In 5 billion years, the starving star will react violently by swelling into a red giant. This expansion will push the Sun's outer boundary into space, swallowing Mercury and Venus. As the star continues to grow, it will engulf the Earth. Eventually, the dying star will shed its outer layers, and the core will collapse inward. It will become a tiny, dim ember called a white dwarf, cooling for eternity. The solar system as we know it will be erased, leaving a dead star in the spot where Earth used to be. Everything we have is borrowed from a star in its middle age.